Welcome dear students, welcome to Spark Academy. I am Nityanand Ghosh, Physics faculty here. So today I will be explaining about a topic called as motion of a particle or a body in a straight line. This is purely one dimensional because the moment 2 dimension, 3 dimension means it will be a plane. So it can be along x-axis, it can be along y-axis, let's say against gravity, with gravity, or it can be along z-axis, whichever axis you are comfortable. So basically it's a rectilinear propagation, the body travels in a straight line. So related problems actually, related to what are the topics that I am going to discuss. So today's topic is I am going to discuss what is the difference between distance and displacement. Of course, in vectors you have studied what is the difference between a distance and displacement. One is a scalar quantity, another is a vector quantity. But we will throw more light on it when a numerical problem is asked. Then how you differentiate between distance and displacement, because it is a little bit confusing. Because you have to calculate the path length. So which path length will give you distance and which path length will give you displacement. Then you have to know about velocity, speed, velocity, average velocity. Then you have to know about different equations of motion, and then how you apply that to a given situation. That is when a body is traveling in a straight line or a body is falling down going up. So all those things I will be discussing. Now so all these are just definitions and all. Motion is in a straight line is the motion of an object along a single straight path. Only one coordinate, either x or y or z, that is enough. So now motion is there. Motion sometime it will start from rest. Numerical problem it's written starting from rest. Starting from rest is your initial velocity is 0. Comes to rest, retardation takes place. Comes to rest means final velocity is equal to 0. Now what is rest? What is motion? If the position of a body does not change with time, with respect to the surroundings, then it is at rest. It is stagnant at one point, so it is at rest. Otherwise it will be in motion. Suppose the body starts moving means all those Newton's laws will act on it, and then we can apply, and then body's motion we can describe. Now next we have to discuss distance and displacement. See, basically distance is total path length traveled. So you have to find out the total path length from initial position to final position. What is the total path length that you have to actually find out, and it is basically a scalar quantity. Displacement is actually the shortest distance from initial to final position with the direction. Are you following? So you have to look for shortest distance. Shortest distance always will be a straight line. Shortest distance will be straight line. So let us go through with some examples. Okay. Now this is one example. What is this example? We are taking a Cartesian coordinate system. X, Y, Z, this system Suppose a body travels from A and reaches B. Body travels from A and reaches B. The distance travelled is del R. How del R? Suppose the position of the body A with respect to origin of the reference frame, let it be position vector Ri, initial position vector. And from A the body reaches B. Rf is the final position vector. So now the shortest distance travelled is displacement. What is the shortest distance travelled? AB. AB is represented by del R. So del R will be equal to Rf minus Ri. Are you following? Rf minus Ri. So here you can write del R is equal to, once again I am writing, del F is equal to Rf minus Ri. Otherwise, triangle law you can apply this plus this is equal to this. So you can find out what is del R. Del R is equal to RF minus RI. Initial this thing, if you want, you can put arrow. So this is your displacement. This is your displacement. But distance travelled is this del S. You see the red line? It's some curve path. Path is more. I have drawn another path. See here another blue line path I have drawn. Okay, this can be another del S. Okay, so this is your displacement. This curve path is your, sorry, not displacement. Curve path will be your distance travelled. This is the total path. Displacement is the shortest distance travelled. Here another beautiful examples are there. Beautiful example is there. Here the body starts from, let's say this point is A and reaches B. Reaches B. You can see this green line, straight line. This green line is your displacement. So green line is your displacement. Okay, because this is the shortest distance travel. And blue line is your distance. Blue line is your distance traveled. See, path length is more actually. It travels like this, then it goes like this, then it travels like this, goes like this, travel like this. So this blue line covering more distance, more path. Always distance will be more than displacement. 99%, 90% of the cases, or maybe 95% of the cases, distance traveled will be more than the displacement. Okay. Now, here there are some other examples. Here this is the example wherein here the particle travels from A and reaches B. Particle starts from A and reaches B. So the shortest length travelled is this straight line A to B. So A to B will be displacement. Now this AB will be equal to displacement. So you know this is a semicircle. This is radius, this is also radius. So R plus R, 2R is the displacement. Distance is pi r. Why? Because the total circle perimeter is, full perimeter is 2 pi r. Perimeter is the total circular length, that is 2 pi r. 2 pi is the 360 degree angle into r. What is semi-perimeter? Semi-perimeter is 2 pi r by 2. So pi r. Pi r is the distance, because only half circle. No? So for this example, distance is pi r, displacement is. This example, a body goes up from point A, reaches up, then comes down to point B. The distance travelled while going up is h, coming down is h. So displacement is 0. Why? Because plus h minus h will be equal to 0. Are you following? But distance travelled while going up, it travels h distance. While coming down, it travels h distance. So h plus h will be 2h. Okay, distance will be actually h plus h. Now this is one classic example where the distance and displacement are same. Why? Because here the body is travelling from this point to this. This is an inclined plane at an angle theta. Body is coming down from here to here. So this inclined plane distance is s. So it cannot leave the system. It travels from A and reaches B here. So distance is s. So both the distance traveled and the displacement is same. Okay. And here another example here, there is a tower of height h. What is the event? A body is thrown up. So body goes up, x, you know that final velocity will be 0. At maximum height, final velocity will be 0. Against gravity it is going, so it will slow down. Suppose the body goes up to here. It travels a distance x. Then again it comes down to the level of the tower. Again it travels distance x. So x plus x will be 2x. And then from here it has to come down, h. So h plus 2x is the distance traveled. Now what is displacement? Please don't do plus h and minus h because it is an event. Event is it is going up and coming down. So what is the shortest distance traveled? The body could have fallen down also, no? So the shortest distance traveled is h. So displacement will be h. So in nutshell what you can say is that distance is greater or equal to displacement. Most of the time distance will be greater than displacement, sometimes it will be equal. Okay. So now this is another example. This is another example. What is this example? If an object turns through an angle theta along a circular path of radius r from point A to point B, then what is its distance? What is this displacement? See, the particle starts from A and reaches B. So this curved path will be your distance. Sector formula you know, this will be your theta. This full angle is theta. So you know d by r will be equal to theta. D by r will be equal to theta. So what is d? Suppose the distance travelled from A to B is d. So d will be equal to theta r. Actually your teacher might have told you in mathematics, suppose this curve length is small, you can take it as opposite side, this is adjacent side. So opposite by adjacent is tan theta. If theta is small, then tan theta is almost equal to theta. Tan theta is opposite by adjacent, no? So d by r. D is acting like opposite side, r is acting like a adjacent side. Suppose you take it as a straight line and this angle is 90. So anyhow, sector formula, so d is equal to theta r. Okay, r theta or theta r is same. But what about displacement? Displacement is the shortest distance travelled. Displacement is the shortest distance travelled. Shortest distance travelled is nothing but this straight line. So what is this? AB, x plus x to 2x. So AB is equal to, this is your displacement, 2x. Now how 2r sin theta by 2 has come? A construction. You drop a perpendicular, this is your 90 degree. Then x will be your opposite side, r will be your hypotenuse. You know, old Harry and his old aunt. In trigonometry you know, I hope you know this. Old Harry and his old aunt. So first letter you take OH, AH and OA. So opposite by hypotenuse will give you sin theta. All those things you know, you are NEET students, so I am telling you. And his, so adjacent by hypotenuse. Adjacent by hypotenuse will be equal to cos theta. Okay, adjacent by hypotenuse. And old aunt, O by opposite by adjacent is your tan theta. Suppose you take a right angle triangle, okay, ABC, this is your adjacent side, this is your opposite side, this is your hypotenuse. Okay, so that way if you take x by r will be equal to, x by r will be equal to, this angle is theta by 2, because this full angle is theta. Full angle is theta, if you half it, This angle will be theta by 2, this angle will be theta by 2. So x by r is equal to opposite by hypotenuse, sin theta by 2. So therefore x will be equal to r sin theta by 2. Okay, so here 2 into x is given, 2 into this r sin theta by 2. So in multiple choice, it can be like this, it can be like this also. Carefully you have to see. So this is one example wherein you have to find out what is distance and what is displacement. Now this is another example. This is another example. An athlete completes one round of a circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? That means one complete circular track, it takes 40 seconds. So first you find out in 2 minutes 20 seconds means 2 minutes means 1 minute means 60 seconds. So 2 minutes means 120 seconds plus 20, 140 seconds. So 140 seconds. So in 40 seconds athlete completes one round. So in 140 seconds, 140 by 40 you do 3.5 rounds. So 3.5 rounds, to apply physics on it, what you do it, you write down this as 3 round plus 0.5, that is half round. Now I told you displacement, if the body comes back to the initial position, then displacement will be 0. Suppose it starts from point A, it goes up, then again comes to point A, then distance is, displacement is 0, not distance, displacement. Provided you neglect the air friction and all those things. So 3 round means, first round it comes back no initial point, so displacement is 0. Second round also 0, third round also 0. So what is additional round, half round? That round will give you the net displacement. Half round means any of this circle, whether this circle or this circle. If you take this top circle, r plus r will be 2r. So the net displacement is 2r, because here 3 round it is 0. This will give you 2r, 2 capital R. Okay. Half round, because it starts from A reaches B. So r plus r 2r. This is the shortest distance. Shortest distance is the displacement. So this problem is interesting. Okay. Now in a nutshell, what is distance? Total length of the actual path travelled. It is a scalar quantity, SI unit is in meter, always it is positive. Displacement is the shortest distance between initial and final position. Of course, it is a vector quantity because direction is involved. Unit is meter, and displacement can be positive, it can be negative, or it can be 0. That you have to keep it in mind. Now next is speed. Speed is distance travelled per unit time. Simple formula. Scalar quantity. Average speed is what? Total distance travelled by total time taken. So whatever numerical problem is being asked, you have to find out, even if it is distance is actually divided into 3-4 segment, you carefully see what they have given. Have they given each segment time or each segment velocity? Accordingly, you apply the formula and find out the total distance, total time. So total distance travelled by total time taken is average speed. Average velocity is equal to displacement by time, total displacement by total time. And there is a concept of instantaneous velocity. Instantaneous velocity is velocity at a particular instant. If you want to write down in mathematical form, limit del t tends to 0, some del s by del t. At a particular instant only you have to find out the velocity, that is called instantaneous velocity. Now let us go through some formulas. Okay, ready-made formulas are there. Suppose average speed is the total distance by total time. Suppose if a body travels a distance s1 in time t1 and s2 in time t2 and s3 in time t3. So what is the total distance travelled? S1 plus S2 plus S3, and total time is T1 plus T2. This is simple. But suppose if they give 3 speed and 3 velocity, time is not given. So you have to actually pull out the information of time. So suppose the first distance S1, body speed is V1, and at S2 body speed is V2. And S3 body speed is V3. So what is the average speed? S1 plus S2 plus S3. This is distance by speed. Distance by velocity is equal to time. Na? You know, speed is equal to distance by time. So what is time? Time is equal to distance by speed. So distance is S1, speed is V1. Like that S2, V2, S3, V3. Okay. Now, suppose they give in this form. First half it travels a speed of V1. Second half it travels speed of V2. Then what you should do? Total distance will be S by 2 and S by 2. 2 is missing here. S by 2 plus S by 2 is S. And S by 2 will come here. Okay, first half means S by 2 is at a distance of V, at a speed of V1, then again S by 2 at a speed V2. So S by 2 plus S by 2 is basically S. And this 2 goes up. If you take 2 common, this 2 will go up. Then what is remaining? S by V1 plus S by V2. Now if you take S common, it will be 1 by V1, 1 by V2. This S and this S cancel. So it will be 2 by 1 by V1 plus 1 by V2. If you close simple algebra, V2 plus V1 by V1, V2 will go up. So if they ask first half distance the body speed is V1, second half distance body speed is V2, then you can ready-made formula, you can use this one. If you want to, there is a paucity of time, you want to save some time, then you can write average speed as 2 V1 V2 by V1 plus V2. Okay. Now, same like this. First 1/3 of the distance speed is V1, next 1/3 V2, next 1/3 V3. So formula is like this: S by 3 plus S by 3, S by 3 is S only. So here distance travelled is S by 3, speed will come here V1. Then S by 3 speed V2, S by 3 V3. 3 will come down. S by 3 if you put 3 will come down. If you simplify, this is the average speed. Similarly, suppose velocity are given, time is given, V1, V2, V3 given, T1, T2, T3 given. You know, distance is equal to velocity into time. So, total distance travelled is V1, T1 plus V2, T2 plus V3, T3 by T1 plus T2 plus T3. Suppose T1 plus T2 plus T3 is T. Then, in place of T1, T2, T3, you can put T. And here because so many T's are there, we don't know how many, so NT. So TT cancel is this. Suppose if the time taken for all the speed is T, then the average speed is nothing but average of all those speed, V1, V2, V3, normal average how you find out. Okay. This is another problem. Okay. So kindly go through this problem. Here, a particle starting from point A and traveling up to B. From A, the particle goes to B with a speed S. S is the speed here. Then from B to C, it goes at a speed of 2S. And C to A, it goes 3S. Then find the average speed. So you have to apply the sector formula. Average speed is total distance traveled by total time taken. Now in this diagram, again this diagram is drawn. 120 degree means in radian it is 2 pi by 3. Pi by 3 is 180 by 3, that is 60. So 2 into 2 pi by 3 is nothing but 120 degree. And this angle is 90 degree. Okay, 90 degrees pi by 2. So this plus this minus 2 pi will give you this. You know 2 pi is the total 360 degree angle. So 2 pi minus pi by 2 plus 2 pi by 3 will give you 5 pi by 6. So this angle 5 pi by 6. Then you apply sector formula. Suppose R is the radius. This is R, this is R, this is R. So R by S is equal to theta. Okay. Sorry. S by R is equal to theta. Theta is pi by 2. Okay. S is equal to R theta. Formula is there, no? Sector formula. So S by R is equal to pi by 2 means S will be equal to pi by 2 R. Okay. Similarly, this will be equal to S, in place of S you have to put 2S by R. 2S by R will be equal to 2 pi by 3. So S will be equal to pi R by 3. S will be equal to pi R by 3. Like that you find out the sector formula and put in this formula. Total distance traveled is AB, BC, CA. That is 2 pi R. Total distance will be 2 pi R, full circle. But you have to find out time T1, T2, T3. T1, T2, T3, this 2 pi R at the end you can put. T1, T2, T3 is nothing but distance traveled is AB by V1. AB is equal to, I told you, AB will be equal to AB by R. If you want you can express like this. AB by R will be equal to pi by 2. So what is AB? R pi by 2. Okay. Similarly, BC by R will be, BC will be equal to R into this theta. Theta is 2 pi by 3. Similarly, AC will be equal to R into this angle 5 pi by 6. 5 pi by 6. So all this AB, BC, CA you substitute there, it will be like this, and then you simplify. Total time is this. Pi by R by 2S, pi by, you simplify, you will be getting 1.8 seconds. Okay. So with this, today I close. I am ending my class. Next class I will solve some more problem and then I will discuss equations of motion and corresponding problem. Thank you.